Okay, so continuing on with our notes from yesterday, what we are going to do now is we are going to go from polar mode back to rectangular mode. So hopefully you see the similarity between what we did yesterday and today, but using our conversions, our goal is to get one of these three expressions, either an r squared, r cosine theta, or r sine theta, because we can use the conversions then. If we have an r squared, we can replace that with x squared plus y squared. And if we have an r cosine theta, we can replace that with an x, and r sine theta with a y. Okay. So I'm going to go through two examples, which you will notice hopefully the similarities with the examples from the first page that we did yesterday. The first example, what you notice is that I have an r, but I do not have these things. Okay, and so what I'm going to do is I am going to first write this as r equals 3 divided by cosine of theta. Okay, because secant is 1 over cosine. Still don't have anything I can use, but I notice if I multiply both sides by cosine of theta, then the cosine thetas cancel out on the right side, and I have r cosine theta on the left side. And we are trying to, remember, go back to rectangular mode. That means we're trying to get rid of r and theta. Our cosine theta is the same as x, and we have x equals 3. And this should be familiar because we just reversed basically what we did in example 1. Okay? So, we should know then that this is a vertical line. Okay. Then let's take a look at the next one, r cosecant of theta. Because this is a little bit different. This is not example 1 or example. So I'm going to try the same thing I did before, where I'm going to rewrite this as r over sine of theta, equals 4. At first it looks like, oh, I have an r and a sine, but I don't. This has to be r times sine of theta. So I'm going to multiply both sides by sine. Now I have r equals 4 sine of theta. Okay, once again, I need an r squared or I need an r sine theta, but I don't have those things. However, if I would multiply both sides of the equation by r, which I can do, because as long as I do it to both sides, it would keep the equation true, then I would actually have an r squared and an r sine theta. Okay, so I am going to take out the r squared and replace it with an x squared plus y squared. And I'm going to take out the r sine theta and replace it with a 4y, using our conversions from the front page or from yesterday. And what's going on here when we see an x squared and y squared, as we talked about this yesterday, that this is some kind of a circle. And so now the rest of what I'm going to do is to try to get this to the standard form for a circle. Okay. So I have an x squared and a y squared, which is great, but I have this kind of pesky y over here. So what that means is that that goes with this y squared, and we're going to have to get it to look like this. So I'm going to leave myself some room. I'm going to subtract 4y from both sides. So I have y squared minus 4y. I'm going to leave a space there, now equals 0. The reason I'm leaving a space here is because I'm going to try to get my y to look like standard form, like this is up here. So what I have to do is I have to pick some value so that I can write it as y minus k squared. Well, if I wanted to write this entire expression as y minus something squared, I could write it as y minus 2 squared, but then I would have to make this a plus 4. And if I added 4 to one side, I have to add 4 to the other side. Alright, let's rearrange or factor this now. I am going to write this entire expression in factored form as y minus 2 squared. This is called completing the square. We've done this a couple times this year. And here is equal to 4. So this is a circle. The radius, since the radius squared is 4, the radius is 2, and the center is 0, 2. Alright, so there's two examples of how we go from polar form to rectangular form. There will be both types of things on your homework. Please check the Moodle website to complete answering the questions from 6-4 day 2. Or if you want to jot them down from here, it's 31 through 34 all, 36 through 54 triples, and 55 through 60 all. That would be for Wednesday.